So today's tutorial is going to show you how to get storage for your functions in Python. But it also includes a number of other elements that might be useful to you. We'll start off by getting a Kubernetes cluster. Now, that could be one that's on your laptop for development using Kind or Minikube or K3s. Or it might be a cloud-based service like DigitalOcean Kubernetes Engine, EKS from Amazon, or maybe GKE, whatever you like. From there, we'll use a tool called Ketchup or K3s Up that can install apps using the Helm chart, but it gets better than that. It installs them in a single click, so one command line, and also gives you help messages to help you get started. So we'll add OpenFaaS, and then we'll add MongoDB. We'll create a Python 3 template, and then we'll link that all together so that we can do an insert and we can do a get. And from there, it's going to be over to you, now that you have those tools, to go and build your own stuff. So I hope you enjoy it. So I'm now going to run you through this tutorial. We're going to try it together. And it's basically to get you started with Python. We use Python 3 and MongoDB for our storage. So right at the beginning, we need an Intel computer. So this, while some of this will work on a Raspberry Pi, that's not really what we're looking at here. We're looking at getting some real work done. And we need a Kubernetes cluster. Now, one of the ways that we can get a Kubernetes cluster is with something like Minikube or Kind. There's even stuff like DigitalOcean's Kubernetes. What we'll do here is we will use Kind, and this is one of the projects that I have recently covered on my blog actually, so let's try that out instead. And I guess the best tutorial that I have for Kind is probably this one on inlets. And Kind is a tool that I guess a lot of people have used Minikube in the past. Kind is one of these tools that has come up very quickly and become really, really popular with the community. So first things first, I want to download it to the current directory and then make it writable. And then I'm going to move it. See, there's actually, it seems to be a typo in the Kind docs there. We'll have to send them a pull request for it. And so we've got Kind now, and we're going to create a cluster. The thing about Kind clusters is that they run in Docker, so you don't actually need anything else special other than having Docker for Mac or a Docker package on your computer. And that's really it. Then you're done. So Kind will take a little bit of time to come up because it's one of these tools that packages all of Kubernetes. The other thing we want is OpenFaaS, and that is pretty easy to install. It's now a one-liner, and we have a CLI for this. And we thought about creating our own CLI to install OpenFaaS, but in the end there were just so many different packages we ended up needing that it made sense to create a more of a generic installer. And this one's called Ketchup. Once you have Ketchup, you get this new command called app install, and it would allow you to install whatever you like. So we'll start with OpenFaaS, and you can set different variables here that would normally be really complicated and hidden away in a Helm chart. How's that cluster doing? Still downloading. If, for instance, we wanted to turn authentication off, that now becomes a flag. If we wanted more than one gateway replica, so we want some HA, again, it's just behind a flag. MongoDB will be installed without any commands, but this is one of the ones that also, I believe, has a couple of options. So just the help and namespace. So depending on what we're actually installing, Ketchup does use Helm, so you can then go and take what you've learned and apply it at work, but it just makes things simpler for us. So here we go. Right. The node is coming up and the kubeadmin config. So now this is the command we want, and we have to paste this into any window. So if we happen to use both of these, we just need to set that now. Let's do the installation. And we'll see that as part of this, Helm was actually downloaded by Ketchup. And this command here is showing how OpenFaaS is already on our machine. It's really that fast. Now, these outputs at the end show us how to install the OpenFaaS CLI. I guess I already have that, you may not, so let's run it. The second command shows us whether the Docker image for OpenFaaS is being pulled and is running inside our cluster or not. Let's see, this is a blocking command. Perhaps what I could show you in the other window is I can show you what's going on. We can watch. And so what we've got here is all of these images are being downloaded from the Docker Hub from scratch. So none of them exist yet on our machine. And each one's being downloaded, put into the library, and then they're coming up. There's some dependencies here, so a couple of them will restart once or twice. But basically, once this gateway is up, we're happy and we're ready to go on. So that's been successfully rolled out. We can now port forward, which is a way of accessing the OpenFaaS UI from wherever we are. And then we'll get the password back from Kubernetes. So this means you don't have to ever remember it. And if you forget that information, you can just run ketchup appinfo OpenFaaS, and it will print it all back for you again. And from there, we could go and deploy something from the store and try it out. But we're not doing that today. Now, the next thing we had on our list after logging in, so we could just check that the login was working. Yeah, is install Mongo. And again, this is going to use the Helm chart. It's going to use all the standard options. And once it's up and running, we then have Mongo, just like that. Now, Mongo has been installed into the default namespace. And we can see again, it's going to take a few seconds to come up, depending on what has to be downloaded. So now, we're going to actually go create a Python function for hello world, and every OpenFaaS image is actually a Docker image. So I have a Docker Hub account, and this is where it's called AlexLS2, and this is where I'm going to push my functions. Fast CLI new specifies a language, and this is going to use one of our templates, and it's going to be called hello Python 3. There we now have a Yammer file created for us. And that just says what folder the code is in. And then after that, we get a handler file and a requirement. So this is all quite standard stuff. And the next thing we might want to do is let's just edit that. So if I open Visual Studio Code where we are, and let's get into the folder. So instead of returning the input, we're going to return hello world. And as per the tutorial, you can use BuildKit if you want. It's a bit quicker. This is an optional step. We then run Fast CLI up. And because we have got the image specified here, this is how it will know to push it. One of the other things we could do, let's say if we've got several versions of this, rather than using a latest tag, we can put something like 010. And then as we have new versions, or we want to control the versions, we can edit it here. Now initially we see that there's 192 megabytes file being downloaded. That is Python 3 itself in Debian. There's recently an article about should Debian or Python with Alpine Linux be used, and I think depending on your use case, I would probably recommend now using Debian Linux because it tends to be a lot more compatible. Now I actually have to log in. otherwise we won't be able to push that. And we run the command again, and now you see everything's cached. It's pretty much instantaneous, and then those images are going to go up. So each time we do a build, it will probably just take a few seconds from now on, and the same with the downloading of those files. Once this has been pushed up from my home connection, we're then going to see a URL for hello Python 3, and we'll be able to invoke it. But just like before, OpenFaaS is using Kubernetes, and we can look under the hood. How's that Mongo doing? It's still coming up. And we can see there's a pod there. You can even watch it. What's going to happen is that pod will actually be downloaded from the internet. So we've come from our computer into a container to the internet, and it will come back down again. And if that seems inefficient to you, maybe it is, but this is a general workflow that you'll have in production, and so it's easier to have the same in dev and production. You can also run your own registry, even on your own computer or on another part of your network, and turns out there's actually a ketchup app for that too. So we're now in a running status. That's great. It means the image has been downloaded, and we go back to our tutorial. It's going to tell us to invoke it using curl. Now we have an error, unexpected indent. So I've actually added one more space than I needed. It's meant to have 4. Well, let's do an up again, and just for demonstration's sake, we'll increase the version. And in a short period of time, see we're only really pushing 26 kilobytes this time, and this is because Docker uses an efficient caching mechanism. Where we are, we'll be able to invoke this. It's now created it and it's running it, and the old one has gone away. So there we are. Hello world. Great. So I also wanted to show you that all of the functions you deploy come with their own asynchronous URL, which means that we can invoke them instantaneously. And you'll see that the timing on this is so quick that that is all being accepted into the OpenFaaS gateway, and it will be running in the background using NAT streaming. You can also set an asynchronous callback URL so that when the work is done, it can come back to you. Now it's time to do the follow GitHub function. Now the follow GitHub is where things get interesting. This is why you're here. This is the Mongo piece. What we want to do is put PyMongo, this is a great tutorial, I actually used it to build some of the content today, into a requirements text file in the folder for that new function. So we now have the data there. Next, we want to do a build to show that that pip module is actually going to be installed. That's on this line. You can see downloading PyMongo, and it's pre-compiled wheel. It's all ready to go. And unlike Alpine Linux, it doesn't have to be built from source. So it only took 3 seconds. Now remember, this is cached. If we build again, 0.68 seconds, pretty negligible now. So remember, we installed MongoDB, but I actually wasn't looking too carefully, and I lost the message. So I'm going to do app info MongoDB. And here it's printed out again, all of the information that we need to connect and even get our password back, which I think is great. So we're going to have some code, and somehow we have to get this confidential setting in of the password and the config of the URL. And the URL is not confidential, so I'm not worried about that. But I do want to create a Kubernetes secret for the root password. Let's try that. Whilst we're doing it, let's see if Mongo's up yet. It's not up yet. Do we have any events? Not just yet. Okay. We'll take a look at that in a second. So there's a secret for Mongo. And back to the tutorial, we're now going to, having fetched it into this environmental variable, create a secret. We use the OpenFaaS API for that, but if we look in the OpenFaaS FN namespace, we'll see the password has been created in Kubernetes. So we want an environmental variable to track this standard path. We're also going to enable some debugging and list what secrets we want. Easiest way to do this is just to copy it straight into our file here. And put that line back that I removed. So the host, the code we'll use is this, and there's a secret. Next, we still have this hello world. So let's go and look at the code. We're going to use the OS import to get the environmental variable that we set for the Mongo URL. We'll use pymongo that we installed through requirements text, and then urllib parse will allow us to quote the password and create a connection string. So that's all in this function. It should be quite standard Python code there. The next thing we'll do is we'll start a connection to Mongo, go to the OpenFaaS database, and then the followers collection, and just insert a hard-coded username. We're going to do all of that here. Just like before, we want to do Fast CLI up, put an F, and then follow GitHub YAML. This is a pretty fast build, 1.9 seconds. And we can get the push and deploy even faster with a local registry. After that, we'll get our URL back and we would be able to go and curl the code. Each time we do a curl, it will insert a record just with this hard-coded username, my username, and the idea of this sample is to show you how you could collect a list of people to follow on GitHub. Once done, really want to look at, well, what's next? Well, I think accepting user import is interesting. It might just be that whatever text is sent on the curl or from the API, we use that instead of the hard-coded string. And then having a query is important too, I feel. So the way that we can do that with a classic template like we're using here is by looking at HTTP method. You might be thinking, well, I'd rather use Flask or something that gives me a bit more HTTP control. That's fine, and there's tutorials for that. But today, we're just focusing on a very basic use case here, which is a function. So what we are then able to do is look and see, is that method post or put? Okay, we'll do the insert, we'll use the request and strip it down, any white space that is. And then for the get, we'll then go back to the followers collection and append each one into an array and serialize it for the user. So that code can be put in now too. And we can run up. Now up actually comprises of 3 different commands: a build to make a container in our library, a push to put it into a registry, and a deploy. And you can run either of those separately, or you can break them out if you want to. And what I'm going to do now is figure out whether there's anything wrong with Mongo. So this is the deployment spec, and normally you will not have to debug these sorts of things. I think that would be a little bit too much to ask, but I do see that it's trying to create a persistent volume, which is the way that Kubernetes stores different parts of data. I'm not sure whether kind actually supports that. So I'm going to go ahead and delete that. see. Okay, it doesn't like us deleting. It doesn't like us using Vim, so we'll use something else instead. We'll use Nano. So here's the volume mount attached to the container. We'll get rid of that. We'll get rid of the volume. And let's see if there's any different. Running exactly what we want. Great. Okay, so, oh, and is it terminating again? It's running. Great. So first things first, we said that we wanted to get a name. So let's put Alex UK as a curl. Record inserted. Right, let's follow OpenFaaS. Record inserted. Inlets dev. And then we should be able to go ahead and get back the list. Right, there's our list. And so we've got end-to-end working Mongo. And if we do this with an I, we'll be able to see that the content type here is text plain, and that's probably not what we want for JSON. So I'm going to go back to the YAML file, and I'm going to put in here content type application JSON, because that's really what we're returning here. I can do an up, but because we didn't change the code, I'm just going to need to do a deploy. You see that's pretty much instantaneous for a configuration change. And we'll see again the pods will have been redeployed and the old one's terminating. And we now have content JSON, so we could pipe this into something like the JQ utility. Perhaps we do a curl with an S to get rid of the input. We now see that coming through. One of the things I think I'll do is I will edit the Ketchup app to disable that persistent volume, because it seems like Kind has a problem with that. I wrote this tutorial using K3D, which is Rancher's lightweight Kubernetes service, and that comes with a volume provisioner. So I hope this has whet your appetite and it's given you enough to know how to at least get your favorite pip module, whether that's Scrappy or NumPy or whatever it be, and write some function around it, write some code and get a HTTP API. The thing that I think you could do next is perhaps use a GitHub webhook, and this is where we can get events out of something like GitHub, and then respond to that, parse it, respond to it, and use that to trigger and build up a database of who to follow. And perhaps the event that you might want is when somebody follows you, you will then go and add them into your list. Now, OpenFaaS does offer some other benefits over raw Kubernetes. Now, I've tried to show you a little bit under the covers what was happening, but you absolutely don't need to even think about it. The Fast CLI allows you to build, deploy, and list functions. It has different templates that mean you don't have to work with Docker files unless you want to. We can log in and have authentication. There's namespace and segregation support. There's even support for logs and for secrets. So we remember our function was called follow GitHub. There we are. We've got the logs and away from one command. Some of the things I think are also interesting is to go ahead and install TLS for OpenFaaS. So if you are deploying on EKS, this is something you're going to want to do to secure it. And then you can look at using stuff like Flask and Docker files. There's a nice tutorial here that goes through how to do everything with Ruby on Rails, but it's the same concepts. So I hope you enjoyed the tutorial. Feel free to send me any improvements that you have in mind. Let me know if this is useful for you, if there's other content you'd like to see coming up. All right. If you do want to get in touch, Twitter and Slack are probably the best way to do that, and you find links here. Okay. So, thank you very much.